In this video, we're going to try and understand what's meant by the range of a function. So you can think of a function as being like a machine. In this case, our machine is squaring the x. So if you put the number 3 into the machine, it will square it to spit out the number 9. So the range is a scope in which the output falls within. So for example, the output will always be above 0. It's everything from 0 all the way up to infinity. You can never, it will never spit out the number -2. It's impossible for you to put a number into here where it will spit out the number -2, because -2 is not in the range. The range is from 0 all the way to infinity. So when you come to state the range, there are lots of ways of stating the range. Range ... anything on the real number line. So this symbol here means belongs to anything on the real number line. So the real number line you would write as a fancy R like this, and then a comma, and then everything x must be greater or equal to 0. So this is how you would state the range. Anything, because for example, you can put the you see 4 is in the range. 4 falls within here, because if you input the number +2 into the machine, it will spit out the 4. But -4, it's impossible for you to spit out a number with a -4. It's just not possible, because if you put in the number -3, when you come to square it, it will spit out the number 9. So it's impossible for you to spit out the number -4. So the range is a scope in which the output falls within. So let me give you some more examples, then it will make sense. So hang on. So if you look at the function f of x equals square root of x, it looks like this. Take my word that the graph, the function looks like this. That's f of x equals square root of x. So here the range. So here, if you put in the number 9, you square root it, it will jump to the number 3. If you put the number 4 into the machine, square root it, it will spit out the number 2. So you see, the range is everything from here all the way up. It's impossible for the machine to spit out a negative number, because look, the number 4 jumps to 2, number 9 jumps to 3, number 1, square root of 1 is 1, it will jump to 1. It's just not possible for you to spit out a negative number. So when you come to state the range, x belongs to anything on the real number line, and then you would specify your restriction here. X must be greater or equal to 0. It can be 0. So and this thing here, this fancy R thing, if you look at the number line, as far as you're concerned, the number line looks like this: 1, 2, 3, -1, and so on. When you get to 16 or 17, you would do what's called the complex. Complex numbers. So the number system looks like this: I, 2i, -i, -2i. So when I say x belongs to anything on the real number line, it's saying that what you put into the machine must lie within this line here. It cannot be a complex number. For example, this here is a number. It just so happens that this is 3 plus 2i. We don't want to put a complex number into the machine. It will break down. So for us to say this, is saying that you can put any number on this real number line. Just don't go putting this I stuff in there. It will break down. Okay, so let me give you another example. Hang on. Let me give you another example. Let's look at the function f of x equals 1 over x, which looks like this. You see, if you put in the number 3 into the machine, you put the number 3 into the machine, it will spit out the number 1 over 3. You see, it will jump to 1 over 3. If you put in the number 5, it will jump to a fifth. If you put in the number 1 over 2, it would spit out the number 2 here. You see, the range is everything above 0 here and below as well, because you can put a negative 3 into the machine and then it will spit out negative a third, which is, you see the range here, in this case, range dot dot x belongs to anything on the real number line, meaning don't put a complex number into the machine, it will break down. You will never be able to spit out the number 0. So basically our range here, you can select any, our range is any number except from 0. So the range dot dot, just now you've got to state your restriction. Just state this: x cannot be 0. So you're able to spit out any number, but it's impossible for you to spit out the number 0. So that's your range here. So think of the range for this function as this. You're not allowed to, it will never spit out the number 0, but it is possible for you to spit out any other number up here and down here. It will never be able to spit out the number 0. Just bear that in mind. Okay, so let me give you another example. Y equals, f of x equals sine of x. This function here looks like this. If you know this, then you know this. If you don't worry about it too much. The highest point is 1. The lowest point here is negative 1. So when you see, it is possible for you to spit out the number 1. If you put in this number here, whatever it is here, it will jump down to here, and it is possible for it to spit out the number negative 1. It is possible for you to spit out negative, I don't know, 0.8 or positive 0.6. You see, the range here is everything up here, everything within this region here. So when you come to state the range dot dot x must belong to the real number line, comma, and then you state your restriction here. So you see x must be greater or equal to negative 1, because it can be dead on negative 1. It must be less than or equal to 1. So this is your range. This here is your range. Let me give you another example. In the future, you will see this function, long future, f of x equals 1 over x squared plus 1. Take my word that the function looks like this. The function looks something like this, where this here is 1. So here, the range is everything here. You see, you can jump to anything within this region. It's impossible for you to spit out the number 2, because 2 is somewhere up here. So the range is it's impossible for it to spit out the number 0, because if you put, let's say, 1000 out here, 1000 squared, and then plus 1 divided by that number, it would be slightly bigger than 0. It will approach 0, but it will never get to 0. So when you come to state the range dot dot x belongs to anything on the real number line, comma. Now the range here is this region here. So and it will never be 0. You can't spit out the number 0. So when you come to state it, x must be strictly greater than 0. It cannot be equal to. That would be wrong. It must be strictly greater than 0, and then it can be 1, because look, when you put 0, well, it can be 1. So the range is within this region. So this is your range here. Let me give you another example. F of x equals 2 to the power of x. Looks like this. Take my word that this function looks like this. So the range here, you see the range here is, well, you can jump to here, you can jump to here, you can jump to here. You see the range is everything all the way to the top. Because if you put in the number, I don't know, let's say 3, 2 to the power 3 is 8. it would jump to the number 8. And so, well, the range is everything up from 0 all the way up. So this would be range dot dot x belongs to anything on the real number line, comma, and then state your restriction. X must be strictly greater than 0. It will never get to 0. That there would be wrong. It must be strictly greater than 0. And then yeah, just this bit here. It must be greater than 0. That would suffice. Okay.